Hello, my name's Relevant. Welcome to the show. This is Do All the Things, and today we're back with this little Fuzz Face Clone pedal I built. I'm gonna give you an update, some of the things that I've changed, and we're gonna discuss batteries. So in a previous episode, I constructed this arbiter. I know it as arbiter. Some people call it a Dunlop. It's a fuzz pace. Fuzz pace. It's a fuzz pace pedal. It's a fuzz pace pedal. I think you know it. One of the simplest circuits on the market and very interesting. And when I first fired it up in the last episode, I wasn't super impressed. Kind of didn't get it. But since then, I've actually played it a lot. It's quite a cute little interesting pedal, especially after I made a correction. You see, right here, we have a 0.01 UF capacitor. I derped out and I accidentally installed a 0.001 capacitor, 1/10 of the value. And well, that pretty much, yeah, it didn't sound good. Kinda, no cojones. That filters out a lot of information. I've since corrected that and found the error of my ways, but I enhanced it. I made it better. Ah, see there, the corrected capacitor is in place. I got those little black dots there for a very specific reason, because I've actually made this component socketable. I can pull it out. I found it changed the tone so much that I wanted to explore what else we could do with this. So that is the 0.1, and I take that out. And one capacitor I've been enjoying is this 0.68. And well, even that, I'm not sure which I like better, the 0.68 or this little ceramic 0.1. The 0.01 I put in there is going to filter out a lot of low end, and it also kind of throttled back the output. Both the 0.68, the 0.1, and the 1 pretty much let the full output through, but will have slightly different EQ profiles. And I prefer the sound of the 0.1 and the 0.068 better than the 0.01. So I'm probably going to put that back in the parts bin. Now you see, I just kind of stick it in those holes. What did I did for socketing? I actually grabbed one of these little motherboard jumpers, and they have pin retention mechanisms in it. I gutted those mechanisms out, cut them in half because they're connected together, and soldered them to the back of the board. It was kind of surgical, it was kind of tricky. Not sure I recommend it. If it's a good idea to you, it's something you can figure out on your own, so I'm not gonna bother explaining the process. But yeah, now I can socket this capacitor. I actually watched this video, this guy JJ10, his dialogue audio kind of sucks, but he knows what he's talking about, or at least that's the impression I got. Pretty much explained me what I needed to know about this pedal, how to actually play it. Now, once I fixed the capacitor in it, some of it became intuitive because it just sounded better. But then, you know, I rarely use the volume pedal on my guitars. That's one of the follies of being a metal player. In fact, my volume control is disabled on the bridge pickup. Never use it. I replaced the potentiometer. I have a 470K resistor across the pickup to simulate the correct impedance load you need. You can't just straight run a humbucker, at least not a Seymour Duncan. They seem to be designed with the impedance load of the pot in mind, and if you run them straight, they sound like ass. But I digress. I got my neck. I use volume on my neck, and this feature right here switches between a standard humbucker and a parallel humbucker. That's important for you to know because the Fuzz Face seems to prefer single coil pickups. When you switch to parallel humbucker mode, not all guitars have that feature, by the way, it cuts the output, makes it brighter, great for clean tones. If you want some of the best clean tones you can get out of an electric guitar, parallel humbucker in the neck. Now you gotta start off with, you know, a cleanish tone with just a touch of breakup. And then we kick on the pedal. If only I was a better guitar player in general. So I'm gonna pull that capacitor out. I'm gonna put the 5.6 in, or no, sorry, 6.8. immediately sounds better to me than the other one. Switching to parallel mode, parallel neck. Neck humbucker mode. You're gonna notice with how much this pedal filters the sound, you don't hear quite that big of a difference between the pickups. Like obviously there is, you can hear it, but it's not as profound as other methods of distortion, amplificationary. So where the magic starts to happen is if you start implementing the volume. For the record, if we go back to the amp, like there's little to no output coming out of the guitar in general, but this guy just boosts it so hard. Very nice, kind of clean breakup. The fuzz adds just enough buzz to kind of clip that signal in a pleasant way. I'm not sure if my miking technique is doing it justice, but I find it pleasant. And since I fixed that capacitor issue and took this guy's tips on how to use the thing, I've had a few sessions here where it's like I was playing it for like an hour, I didn't want to put the guitar down kind of situation. Now just for reference, I gotta pull the 6.8. I gotta put the 0.1 in there. 0.1 ceramic, you know, kind of a little bit different. See if you can hear the difference. It's like a little bit more saturated, a little bit more. Yeah, I can't make up my mind whether I prefer the 0.68 or the 0.1. Either way, they're both better than the stock values. So I recommend giving it a try if you're gonna build one of these pedals. So, one of the questions that's on everybody's mind is the Voodoo of battery versus power supply. I think it's kind of true. I put a battery in this and it did sound better than using a power supply. Now, if we look at the circuit, there's like no power conditioning whatsoever in this pedal. None. It's raw. So it is going to be a design I think just sounds sounds better with pure DC, simply because certain aspects of switching noise that a power supply is going to create, unless you get something particularly high end, it's just going to interfere with the circuit. And even though on a technical level it should function the same, it's possible for those frequencies coming in the power line to affect the kind of way the transistors respond to the frequencies coming into the signal lines. So I guess I could see some truth to that Voodoo. I questioned whether or not it has something to do with power curves, like maybe the pedal was putting some sort of voltage drop that a power supply would be too stiff to respond to, but a battery would respond to. No, not so much. Right off the hop, we see that this pedal idle is pulling, that's 1.2 milliamps, just over a single milliamp. Let's set these bias halfway. Yeah, 1.19. Let's feed it a little signal. Cranking her. It actually consumes slightly less power as you play it. So what does the battery think about this? So this relatively fresh battery, it sank down to 8.93. Let's unplug the pedal. 8.95. If I was going to use the colloquial term, the battery gives 0 Fs. There is absolutely no voltage drop whatsoever out of an alkaline battery. Now I went and calibrated this pedal to this battery. Let's see how that calibration held, because of course that's going to change with battery voltage life. 4.24, that's gone down. 7.1, that stayed about the same. Now the rumor is that these pedals sound even better with carbon zinc batteries, not alkalines. It just so happens the local dollar store has these Panasonic carbon zincs for like $1.25 each. The capacity of a carbon zinc is rated for about 400 milliamp hours. An alkaline is 500, but we'll go with the carbon zinc. Theoretically, if we start with 400 milliamp hours, and we divide that by 1.2 amp power draw, that's a theoretical over 300 hours of use, which I find hard to believe. And well, that's gonna be a case because if you're aware of the power curve of a battery, and you might be aware that in your time scale, the power of an alkaline, and I believe it holds true for a carbon zinc, drains gradually to the point where, maybe not even 50% of its capacity, the voltage drops to such a point that the battery's not useful anymore. I call this a half-life. I say that disposable batteries have a half-life. They're only good for half their life. If you compare that to a good rechargeable battery, they drain kind of more like this. Now, a rechargeable battery by nature doesn't have as much capacity as an alkaline. It's more consistent capacity, but it's one reason why they get a bad rap, because you might be using a rechargeable battery and a flashlight and then it just suddenly dies on you and you think, oh, what a piece of crap. Whereas, the alkaline battery boils the frog. It goes down so gradually you don't even notice it's dying. Until you replace it, it's like, oh geez, my flashlight was only running at half brightness. That said, a rechargeable battery might be advantageous, and that's something that I want to try. Now, one of the first problems we have with rechargeable batteries, an individual rechargeable cell doesn't have the same voltage. A disposable cell is rated for an average of 1.5 volts. A rechargeable cell is rated for an average of 1.25 volts. The total output of this battery is rated for 8.4 volts. To make matters worse, the rated capacity of this guy is only 175 milliamps. That would be a theoretical still 145 hours of use, but technically, unlike the disposable, we're more likely to get its rated capacity because of the more consistent voltage drop over its capacity. And once upon a time, you didn't want to use rechargeable batteries because they would die on their own. But that's a thing of the past with these new low self-discharge nickel metal hydrides. These come pre-charged. This guy's ready to go. I connect the meter on it, it's 8.95 volts right now. It's going to sag down and settle at a lower voltage, but it should provide us some good usefulness. 8.9 volt. Let's see if we can hear a difference. You know, I'm not sure. I feel like there might have been a little something there, but then I remembered as I was playing it, when I did the test, I didn't do the test with the alkaline battery, 8.94 volts. I did the test with the carbon zinc battery, which is clocking it at 9.6 volts, 9.59 volts. So, under normal circumstances, you know, if the carbon zinc starts at a higher voltage, maybe that's why the old Fuzz Face sounded better with carbon zincs, because it overvolted it a bit. Maybe our bias specification is off. Oh, let's look into this further. So let us go here and check our bias. Once again, they say to set the controls halfway. So our bias is 4.87 volts right now on that rail. Now let's go and test the other rail. I, by the way, added little friggin' pips in there to clip my leads to. 0.71. So in theory, because we can adjust the bias on this pedal, there's no reason we shouldn't be able to run a rechargeable battery. An op amp needs all the voltage you can get, but when your pedal runs the actual circuitry at a lower voltage, you can adjust on it. So 6.9, let's bring that up to 7.1. And then this guy here, which is touchy as frig, it actually takes quite a bit of time to bias this guy. Let's bring it up to 4.87. 4.86, is that close enough? Now you gotta go back and forth because it keeps changing, right? Oh, 7, it's fine. Blip it back to 7.1. 483. We'll stick with 485. We're going to be here all day trying to hit that individual number. And if there's one thing I've learned, it's not that important. We will set this one to 7.1 though. In retrospect, these pots are touchy. I don't know if a 100K pot in this position was a good idea. I think maybe more like a 20K. Close enough. Can we hear a difference in sound? At this point, you're not sure if you're hearing things or if it actually maybe sounds a little bit better like this. I don't know. At any rate, at this point, I think it's safe to say that if you have one of these clones with the adjustable bias, you're good to run a rechargeable, buddy. Now, the voltage it's running at right now is subtly unnatural, 8.92. Surely at 8.4 volts, it's gonna sag down, but once it hits that sweet spot, it's gonna be more consistent. Update. It's too soon to tell, but I think I might have figured something out. Okay, so we have this pedal. We calibrate it based on 9 volts to a bias of 4.5 and 0.071 as per specifications. If I'm doing my math right, that is a ratio of 15%. 0.7 is 15% of 4.5. So we found this value here, 487 and 071, where when we put in the carbon zinc battery, it sounded a little bit better. So I put put in the rechargeable battery, and I calibrated it for this. As an experiment, off camera, I put the carbon zinc back in, and I'm like, whoa, that magically sounds better. Is there something to this, Voodoo? And then I checked the bias, and it fell in at 5.34 and 0.74, which actually works out to 13.8%. I'm writing this upside down, so that looks like it says, well, that 3's backwards. So based on 13.8%, I took a value arbitrarily of 5 volts, got 13.8, I got 6.9. And sure enough, even though that number's different from that number, it sounded similar. So when you change the voltage that you apply to the pedal, the bias between the two transistors doesn't apply proportionally. That ratio is going to deviate. The 0.7 raises slower than the 4.5. The 4.5 will start to go up. It's quite touchy. But then the 0.7, it only changes by a small margin. So we widen that margin, and sure enough, I put the rechargeable battery back in, biased it according to those numbers from the carbon zinc, and it sounded awesome, just like the carbon zinc. And then I used this formula, arbitrary 13.8, 505 and 069, and it still sounds awesome. So maybe I've stumbled upon a slightly better bias value, and it might explain why some batteries sound better than others. That was the point of this video, to figure out why some batteries sound better than others. It has to do with their voltage. That carbon zinc putting out way more than 9 volts is, you know, batting pretty high average right now. And again, because this thing needs way less than 9 volts, we can calibrate a weaker power supply to run it. So, something to consider. You know, you got your custom bias in this, maybe play with those numbers a bit. As long as they're within a certain range, you might get some interesting results. I almost question the implementation of regulation in this pedal. If we used a Zener diode across the input to, you know, pull the voltage down, you know, we get something like an 8-volt Zener diode, so that no matter what battery you put in here, it's gonna pull it down to 8 volts. Now, mind you, that wastes power, right? Yeah, that brings up an interesting point, because you might notice I didn't have an LED in this. At 1.2 milliamps, that's extremely low drain. Even my overdrive pedal here, the op amp, it averages like 2 to 3 milliamps power draw. An LED can pull 5. An LED is literally sucks more juice. It's just a battery drainer. That's why you see these pedals not with LEDs, because it's kind of a stupid idea. It makes big battery happy, but not me paying the bills. Especially, I'm an individual who doesn't like to be a disposable dink. I don't really want to use disposable batteries in my pedal. I think at this point in time, I'm gonna remove the DC jack and just run this exclusively off batteries. You know, it gives that more authentic vibe. So yeah, let's go ahead and do that. Okay, buddy. We're going in. Ooh. What I'm gonna do, just to make this a heck of a lot easier on me, is like, I'm just gonna clip the battery leads. We're not gonna need them to be this long. Oh, no, we gotta take this apart anyway, because that negative. I keep getting, this guy's backwards. I keep getting confused. It goes directly on the board, right? So we're gonna have to solder the battery terminal directly onto the board. All right, we gotta take this all apart then, bud. Okay, where's that power connection? Oh, right there. I guess we're gonna need our vise. Now I had an idea where if I was building one of these for someone who had a pedal board, I would include the DC jack, but I would connect it to something like a relay so that you could leave the pedal on the pedal board plugged in with the battery in it, but when you unpower the pedal board, it switches off the relay, switching off the pedal. I think that would be a reasonable compromise. Wonder how well a little solid state relay would work. Or maybe just a MOSFET, even though MOSFETs by nature they're gonna use a little bit of power. I guess since I got this open, you can take a look at the little pin assembly. Can you see those? Soldered on there. It looks ugly, but it works well. Kind of anyway. My next parts order is gonna have some component sockets so I can do something like that, but more official. Pretty much have to gut the whole damn thing to get things routed the way I want them to. All right, I think I got retooled back to battery only. Looks surprisingly more empty in there. Let's get the crystals back into place. But now I have this hole. What am I gonna do about that hole? Oh, well, the only thing I can do right now is jam a grommet in there to dress it up. Maybe we put an LED there. No. Now, it's worth mentioning that I actually damaged one of these pots. This guy right here kind of ripped out. These TT pots are a little bit fragile, so don't use a pressure fit knob like those mismatched ones. You're gonna notice I changed the knobs. I got these cheap Chinese Marshall knockoffs, and they look really nice on here, actually. So what I do is I'm gonna get this piece of paper. It's a gum wrapper. Put that there to use as index, because these knobs will go all the way down to the paint, and we don't want that. And we pull that out and it should spin freely. Aha. All right, so we're back to Doorbell here just now with no DC input jack. So, which one of these two batteries do I think I want to run in this thing, sir? Carbon zinc or Energizer recharge? I think I'm gonna go with the Energizer because I have it calibrated to it already, and we'll get a chance to see how much usage I'm gonna get out of this battery. We'll see, I'm gonna have to make up my mind. In the meantime, I think that's all I have for you today. Just wanted to update you on this pepperoni, let you know, hey, try a different capacitor. Hey, use a battery. Hey, you can use a rechargeable battery if you could rebias it, in which case I can. And if you're building a clone based on Electro Smash's recommendations, you can too. We don't gotta use a 9-volt carbon zinc disposable. So if you're really one of those eco-friendly people and don't want to use disposable batteries, you don't have to. This is a compromise, even though this guy costs like $15, $20 here in Canada. That's fine, it's an investment. So, I hope you enjoyed this. Stay tuned for more, because I'm gonna be doing more work on pedals, I've decided. Not exactly sure what yet, but I'm probably building a couple more pedals. So if you like pedals, come check it out, bud. Cereal, check it out. Got nothing to lose, it's free. I'm not even asking you to go to my Patreon, which I do have, by the way. But it's like a freaking ghost town over there, and I'm just like, whatever. I don't even know how that works. How do you get people to sign up for your Patreon? Why would anyone want to? I guess I don't get it.